Okay, question 4 clearly looks like a straight line question. So the first one is the line L1 is the altitude through B. Find that equation. So I would be drawing that on first of all. So the altitude through B is going through point B, and altitude makes connection with this line at 90 degrees. It's perpendicular to that point. Okay. I would also at this point just write in my various points just to help me out. And A would be -5 and 1. So for question 1, I would do the headings P, I'll do G, and I'll just put E below here. So what point have I got? Well, I know I've got 3, 1, okay, that's all I've got on this line. So to find the gradient, I'm going to need to find this gradient and do the perpendicular gradient. So I'm going to write that down as MAC. And you could, if you wanted, write these points in here and use it to work out. That's fine. Don't write them in here though, because it'll get confusing as to which points are which. Okay, but right now I'm going to just label them up as x1, y1 and x2, y2. So that's going to give me, let's keep it in red, -5 take away 1 divided by 4 take away -5. Let's keep that in bracket. So that's going to be -6 and 4 plus 5 would be 9. That's -2/3. And this is where having the notation nice and neat helps, because that's MAC. I don't want MAC, I want the gradient of line B. So that just helps you to remember that the perpendicular gradient, change the sign to plus and flip it over. So just take your time, nice and neat. And my equation is always in the form of this. You could just write that down straight away. And this is where putting the point in on its own is very good, because it just declutters your sheet. Okay, if you've got all the points up here that you use to work out the gradient, you might put in the wrong point. So just be really careful with that. Take away 3. I'll times 2 through by 2. 2, and then that becomes 3x take away 9, because the 3 stays here, then multiply the bracket out. And then I'll write it with the 2 on the other side. So that'll be take away 7. And if you wanted, you go a bit further again. Just divide through by 2. It's up to you. I think most people would have just stopped here, which is totally fine. Let's just check the marking scheme. So question 4. Yep, so you're actually getting 2 marks in here. So a mark for your gradient and the perpendicular gradient, and then a mark for your final answer, which they have got in this form. 3x take away 2y is 7, but yeah, same thing. So that's your 3 marks for question 1. Question 2. The perpendicular bisector of AB. The perpendicular bisector of AB. Okay. There's 2 words to note there. Well, the first one was the altitude, okay, so we could have underlined that. But perpendicular and bisector. So if I was to draw that in, I think at this point I'm just going to rub out my x's and things. And I'll do this in blue just to make it clear. The perpendicular bisector means it cuts AB in half, so it's going to cut right in the middle. So maybe the middle's there, I don't know. But it also is going to cut it at 90 degrees. Okay, so that line is at 90 degrees to AB. Okay, so same again. I've got P, G, and I've got E. So I should have called that A and B. Okay. And my first point is going to be the midpoint of these two. So the midpoint is just adding your x's. So the midpoint of AB, it just means adding my x's and dividing by 2, and adding the y's and dividing by 2. So -5 and 3, that's -2. Divided by 2 is -1. And 2 divided by 2 is 1. Now you can just check you've done that right by just drawing it up here. So write -1, 1, just to check it's okay. And we'll just look at the difference. So here the difference is 4. So I've added on 4, okay? And then to go from there to there, I've also added on 4. So that looks good to me. And from 1 to, oh, this doesn't look right. Oh no, yeah, it does look right, okay. So the 1s are just the same, aren't they? So because that's a horizontal line, the y value is the same. So the difference is 0 and the difference is 0. So actually, yeah, that looks good for that. So I'll just take that off. It's a bit messy, but the point is you can visually just double check you've done your midpoint right. It's very easy to make a silly mistake in these questions, so it's just worth noting how can I make it a little bit different. All right. Now that's actually got me thinking for the next bit, but I'll just do the sum anyway. So the gradient, I'm looking for the perpendicular gradient of AB. So I'll be saying that MAB is y2 take away y1 divided by x2 take away x1. So I've got 0 divided by 8. So the gradient for that one is just 0, isn't it? And that makes sense. It's a horizontal line. You didn't even need to do this sum. You could have just said, well, I can see that m is equal to 0. That means that our gradient, though, that means that the m perpendicular is actually undefined. So we're not going to use this classic equation. We're not going to use this. That doesn't now work. What we have to just do is say, well, it's clearly a vertical line. So what's my x-coordinate? Well, x-coordinate is -1. So that means that x is always going to be equal to -1. Because our line, I was actually quite close to the point, isn't it? Like, it's just going straight up, so the x-coordinate stays the same, and it's the y value that will change. The opposite of this line, where the x-coordinate was always different, but the y-coordinate was always the same. So x, so just a slightly trickier one there, slightly trickier one. So you're getting your mark for your midpoint, a mark for knowing this was 0, and then a mark for knowing about your final equation. So not bad. And have we got time for the last bit? Yeah, we do. Determine the coordinates of the point of intersection of these two lines. I'll do a space over here. Okay, so I've got 2y is equal to 3x take away 7, that's line 1. And line 2 is just x is equal to -1. So this is actually a little bit easier than usual. Many people would be confused by it because it's different to what we usually do. But clearly, the x-coordinate, they're going to meet when x is equal to -1. Obviously, because this has always got x is -1. Yeah. So you're trying to find out this other y-coordinate. All you need to do then is substitute in x is -1, don't you? So if I said then that L1 is equal to 2y, 3, and I'll put in a -1, and then take away 7, you're saying that 2y is equal to -3 take away 7. And you're thinking, now this looks good, I've got a reasonable number here. So -10 and then -5. And we'll just sub that up there. So they will meet at -1 and -5. And you don't get a mark for that because you're really just substituting in a number. So it's not a huge amount of working. But yeah, I quite like that question because it's slightly different to what we've usually had. We've usually had a wee bit of simultaneous equations down here. And also this would have thrown a few people. I can imagine someone going, wait a minute, this makes no sense. And actually the drawing here was quite helpful because without that drawing, maybe people would have thought, oh, is that vertical or horizontal? I don't know. But I think this can give you a little bit of, oh yeah, okay, horizontal line, vertical line, I understand what's going on. So if this wasn't drawn, again, you could draw a rough version of that, on your sheet. You could just make sure you roughly draw the points in where they are, and you would hopefully spot, oh, wait a minute, they've got the same y-coordinate. So yeah, nice little sub marks. As I always say, straight lines should be in the bag. It's easy to make a mistake, but there's lots of good points to be had there. So just take your time and PGE all the way. And this was good. We got to go through all of our different points here with the medians and if you know about medians, the midpoints, and you know about the altitudes, the 90 degrees, there's not much more they can ask you apart from this perpendicular bisector, which is kind of just putting them together. So yeah, hope that's helpful.